So, good afternoon, Professor Rami Burstein, and it's been an honor and a pleasure to interview you regarding the impact of basic research into headache medicine. So, and we are very grateful that you have taken out your time to answer the few questions for the benefit of numerous members of International Headache Society and primarily for the education purposes. So I would like to ask you a few questions, and we would expect that your answers will generate a lot of interest into the basic research that goes into the headache medicine. So the first question is, how is basic neuroscience research contributing to the understanding of migraine?
So the answer is way beyond the question that you're asking. The philosophical answer is that basic research should attempt to answer questions in animals that are ethically inappropriate to try to answer in human. In other words, questions that we can answer in human because ethically it's right and we are not putting patients at a risk, should be answered in human. And questions that should be answered in animal studies are only those questions that we cannot answer in human. And the reason for it is that no matter what we do to animals don't live 90 years. We can't induce a migraine in animal between age 14 and 60. And animal models, no matter how hard we try, have a limit level of ability to confirm what will happen in the clinic. And in fact, most animal studies lack the ability to predict whether what we find in animals we will find in human. So if we agree with this understanding that we should only ask questions in animal that we are not allowed to ask in human, I think that it immediately focuses our studies on questions that can only be answered in animals. And this question really defines the contribution of basic neuroscience to the field of migraine or to the field of headache in general. We know that not sleeping enough can trigger a migraine. We know that skipping a meal triggers a migraine. We know that migraine can have an effect on cognitive functions. Will we be able to answer a question on how neurons in the brain that regulate sleep and appetite and stress can initiate a migraine attack, trigger a migraine? Probably we can't. We have to go to animal studies to try to explain why is it that patients get migraine when the stress is over, not during the stress? Why is it that when you sleep too little, you get a migraine, yet so many migraine attacks begin while we are asleep? So is sleep a protective or not a protective? Why is it that skipping a meal triggers a migraine? How do the neurons that determine how hungry we are and should initiate the behavior of feeding can trigger a migraine? These kind of questions can only be answered in animal studies, and this is the basic science contribution to the pathophysiology of migraine. It takes clinical observations. Why this is a clinical observation?
Yes.
Why is your hair painful or your scalp sensitive? This is a clinical observation. We would never think about in animals. It is the animal data that allow you to understand what is peripheral sensitization, what is central sensitization, how is it that light can make the headache more painful, how is it that sleep can allow the brain to turn on a migraine headache that end up with a pain around the eye. This is the contribution of basic science, trying to understand things in migraine pathophysiology that are based on clinical observation that we cannot explain in human because it has a molecular and cellular and physiological and anatomical basis that we cannot answer in human, even with the advanced imaging techniques.
Correct. So what you want to emphasize by this, that despite the constraints of human models not exactly matching the human's behavior and human diseases not matching exactly the animal models that have been produced, but we tend to get a lot of answers which otherwise will be impossible to get by doing the human studies alone.
Oh, the human studies has huge importance.
Right.
Right. If we say that infusion of a drug trigger a headache, this is the clinical observation. How this drug trigger a headache? It can happen in a periphery. It can involve an effect of a drug on a neuron, on the immune system, on the vascular system. It can happen in the brain. It can happen in the spinal cord, in the brainstem, in the thalamus, in the cortex, in subcortical areas. If we don't do that, we are missing an opportunity to understand pathophysiology. This is where the clinical data takes you into the basic science. To infuse a drug into animals and show that the animal has a von Frey hair that they jump like this is not helpful. It is not helpful. It's helpful to when you start in the clinical. And I think that maybe the most important statement that I'm going to make here is that the concept of bench to bedside is, I truly believe that it's completely wrong. It has to be bedside to bench. Research that went from bench to bedside was mostly wrong. Research that starts in the bedside with the patient and end up in the lab works much better.
Oh, that's a wonderful insight.
And this is a fundamental philosophical approach to basic research, that it has to be bedside to bench and not bench to bedside.
I do remember seeing one of your presentations in which you showed a cutout skull with a throbbing artery, right? And you then link it to the sensitization,
Right. So patient tell you that their headache throbs. Animal will never tell you that.
Right.
So it's a basic research that explain why migraine headache throbs. What is the neuronal mechanism that actually make it happen?
Correct.
It is eventually the basic research that explain to you why it hurts only here, and why migraine does not hurt in your toes or in your teeth, right?
Right. Fascinating. So the next question is that can you just summarize? Although I know it's quite a vague question in a sense that it's very wide, but from a neurophysiological point of view, what do you think that how much of the migraine pathophysiology that we understand as of today, and how much is left?
So I think that we understand about 1%, and 99% are left. By far, the easiest part of studying the pathophysiology of migraine is related to the headache, right? Why does it, which pain fiber mediate it, what happened in the spinal cord, brainstem, thalamus, and cortex. The pain is relatively easy because we can study it in animals. The things that are missing is everything we talked about until now. We don't have an understanding of how light can make the headache more painful, how noise can make the headache more painful, why perfume, how is it that perfume can trigger a headache. We don't understand, we have no understanding of how any trigger a headache, how being too hot trigger a headache, why is it that flying trigger a headache, what is it about not drinking enough to trigger a headache. It has a pathophysiology. We don't understand most migraine symptoms, associated symptoms. What is the mechanism for nausea induced by migraine? What is the mechanism for dizziness that accompany migraine? Why are the muscles in the neck begin to hurt 2 or 3 hours after the migraine starts? Why is it that we can't remember simple things when we have a migraine? What is the relationship between migraine and hormonal changes?
Mm-hmm.
We know it's there from clinical studies. We don't know how.
Yes.
So the pathophysiology, really, if you leave alone the headache and you move into all the prodromes and the triggers and the associated symptoms, we really don't know the pathophysiology. We can't explain all of that. We can't explain, well, we will not know why we yawn before the migraine attack. Take this one away. How is yawning, which is mediated by many brain areas, but let's agree that the hypothalamus is involved. How is yawning end up with a pain behind your eye?
Correct.
Or a pain in your temple? What happened between yawning and the onset of headache? Clearly, you need to activate the pain fibers. What is it the hypothalamus does on a chain of events that eventually give you a headache around the eye? Is it that it's always there, but now the cortex knows about it? Is it possible that this neuron tell the thalamus, now you can tell the cortex that there is headache? It was always there, but it was blocked, and now it's not blocked? Maybe it's too simplistic, but it is possibility. What I'm telling you is pathophysiology of migraine is in a total darkness on prodromes, triggers, and associated symptoms. And if you agree that yes, the headache is the most disabling part of migraine and it is what causes suffering, but everything else, especially the cognitive decline, the transient cognitive decline, it's not the only one. The sensitivity to light, that they have to go to a dark room and they can function, they can be with their kids and can keep working. These are all have equal importance. And the fundamental part is that I think that we do not know the answer to this question. I think that the generation of scientists that come into the field now will have to focus on all these aspects, because the headache itself is the one aspect of migraine that we know.
Correct.
Something. We don't know everything, but we know enough to use it to contribute to our understanding of the headache phase of migraine.
Right. So your answer actually reminds me of the fact that astrophysicists say that we only know the 4% of the universe. The rest 96% is still a mystery. So migraine still is a mystery. And I think a person like you and others who are doing significant research in the basic sciences will, in days to come, will unearth the various pathophysiological aspects. And more importantly, as you rightly said, that headache is not migraine, just headache, because migraine is much beyond headache. There are a lot of other things to be considered for migraine. Okay, so the third question is that, do you believe that is there any migraine generator in the brain?
No, I don't.
Right.
It's a really simple answer. We used the word generator 50 years ago when some scientist lesioned a part in the lateral hypothalamus or medial hypothalamus and made animal not stop eating or not eating at all. So they either get obese or get too thin. And said, the lateral hypothalamus is the center of eating, and the medial hypothalamus is the generator of anorexia. This was so oversimplistic. There isn't a single function that we can think of that involve one group of neurons in one part of the brain. Everything is a network of neurons. If you talk about sleep, there are 17 nuclei with different chemical neuropeptides or neurotransmitter in the brainstem that play a role in the regulation of sleep. Sleep is brainstem, sleep is hypothalamus, like 4 different group of neurons in hypothalamus. Sleep is the basal ganglia, sleep is the thalamus, sleep is the cortex. Can we talk about the generator of sleep? No, we can't. Can we talk about the generator of migraine? Look, we went there with a PhD. The PhD was supposed to explain for 10 years, the world of headache was locked on the fact that there is somebody sitting in the brainstem and turn on a switch so you get a migraine. The PhD is regulated by the amygdala and the hypothalamus and the basal ganglia and the cortex and the spinal cord. It integrates. Is it a generator? There is no generator of migraine. There are networks of neurons that involve the brainstem, the hypothalamus, the thalamus, the preoptic area, the septal nuclei, the amygdala, you name it, all of it, the prefrontal motor cortex, the somatosensory cortex, everything. There is no migraine generator. There are complex networks of neurons that play a role in different aspects of migraine.
Yes, I think I completely agree with you that it will be too reductionist to bring it down to a generator level when we know that a lot of networks are actually being involved. So the next question obviously comes as a follow-up to this, that what do you think about the peripheral contributions to the migraine pathophysiology? Because recently you have also published a lot of research on the cutaneous nerves in the scalp and their connections. So what do you think about the peripheral?
So there is a simplistic answer and a more complicated answer. The simplistic answer is that I belong to a group of people who believe that you cannot have a headache without activation of peripheral pain fibers. This is only one aspect of the contribution of the peripheral nervous system into migraine pathophysiology. But if you think about the fact that pain has the ability to change the brain, you now turn it into a way more complicated thing. So if pain invades the brain and over 40 years you have repeated migraine attacks that last 1 or 2 days, sometimes more in chronic migraine patients, and they send millions of pain signals that spread throughout the brain, right, to the brainstem, to the hypothalamus, to the cortex, to the thalamus. When pain signals that start in the periphery eventually get to neurons that regulate sleep, for example, and keep releasing neuropeptides there and changing the way these neurons respond. They make them hyper-excitable, hypersensitive, hyper-responsive. Now you realize that pain changes the brain. It changes the cortex, it changes the hypothalamus, it changes every area that receives these painful signals. This is the true contribution of the peripheral nervous system to migraine. It changes the brain.
Right.
And if you take it away completely, if you take a migraine patient and you eliminate the pain, and you give them 5 years with no pain, it is very likely that most of the sensitivities that create prodromes and that create triggers and that create associated symptoms will go away. Maybe they will no longer be sensitive to light at all. Maybe they will no longer notice prodromes, like we all yawn, but we don't get headache. They'll yawn, they will not get headache. Maybe it will allow them not to sleep enough and not get a migraine, to drink wine and not get a migraine, to get stressed and not get a migraine. It will, because the neurons that are involved in making or mediating headache by, for example, insufficient sleep, will return to normal activity. So the peripheral nervous system is not only sending pain signal to the brain, it changes the brain. Right? If you do like this on your skin, nothing happened. But can you imagine you did this for 25 years? The skin will get all blue even though you did it really gently. Can you imagine doing few billions times this one on the skin? Eventually it will become painful. It will change the skin, right?
Right.
I think that it's the same with pain. Pain sends low level of the headache phase of migraines invade the brain with continuous, not continuous, with huge amount of repeated pain signal. Pain is not good for you. It changes the brain.
Right.
We know it from functional imaging. It changed the brain, right? The cortex get the gray matter volume get bigger and get smaller. It changes. The brain changes with pain. This is the real contribution of the peripheral nervous system to migraine pathophysiology.
I think that's very profound, and I think that even in other conditions of chronic pain, we have the evidence that that the fibers so long were kind of contributing, like C fibers or A beta, is now being changed to A delta is going to A beta fibers. So that changes.
So the sensitization is a part of it. It's a part of it is a part of how pain signal change the pain pathway within the brain. But until now, we only thought about it in the context of pain is not good for you because it creates sensitization. Sensitization plays a role in the chronification of the headache. But this is only one aspect. Pain reaches almost every brain area, right? It reaches cognition, it reaches memory, it reaches emotional responses, it reaches mood, right? It plays a role in depression and anxiety and anger and irritability. I mean, why do migraine patients get so irritable when they have a migraine? They want to stay alone. Pain will do that, right? It's not because they're irritable they get a migraine. It's because they get a migraine. They get upset and angry and sad and they cry.
Absolutely. Okay. So so now with the there is also a major concern, especially for the clinicians, when the migraine becomes high frequency migraine or they transform into a chronic migraine state. So do you think that chronic migraine is a different disease than an episodic migraine?
No, I don't. I think that it is a continuum.
Mm-hmm.
I think that in chronic migraine we see brain that change to the extent that's going to make it much more difficult to reverse. But I think that what is missing here is the distinction between chronic migraine and chronic episodic migraine. Migraine is a chronic disease, and it comes again and again and again.
Mm.
And I think that the difference between chronic episodic migraine and chronic migraine is that in chronic migraine, the changes that occur in the brain, for most part, become almost independent of the pain signal that come from the periphery, not only in the headache itself, but in any other aspect. That's why even when they don't have a headache, they're still sensitive to light, and they still are afraid of drinking wine and doing things because the chronic migraine brain changed to the extent that it will take much longer intervention to bring it back, to do what we call a disease-modifying approach. In chronic episodic migraine, we really don't need to modify the disease. We need to stop the pain and let the brain long enough time to recover. But I don't see how it is fundamentally different, beside the fact that the changes in the brain become somewhat independent.
Okay. And so at the moment, can you just brief us about the current experimental models that are used for the study of migraine?
I think that it's a brief answer. We all mature enough to know that there's more than one truth to migraine, and that animal model that study aura on corticospastic depression is very different than animal model that try to understand how CGRP trigger migraine, or how nitroglycerin trigger migraine, or how inflammation trigger migraine. An animal model, there will be animal model that is only good for photophobia, and there will be animal model that is only good for headache, and be animal model that is only good to study sleep effect and cognitive effect. They will all need their own animal models.
Okay. So many headache researchers actually wonder that how can they create an experimental lab in their unit, except for the highly resourced institutes like you or the Danish Center. There are a lot of other research centers which find it difficult to establish a headache lab, basic lab. So what do you suggest?
So I'll give you two very short answers. The first one is you can't do research without money. It is you just can't do it. You need to have money to do research. It costs. It's a fact of life. And this is the best use that we do with our money, is generate new knowledge. I think that the second answer, which is more reasonable, is that they all have to understand that it's not a popularity context, and that you don't have to agree or disagree with anyone. What you have to do, because there's more than one truth to migraine, and it's okay for you to disagree with data that exists. And the most important part is that you ask questions that nobody before you asked, and that by definition, if you want to do research, you have to ask questions to which no one in the world can give you an answer, because there is no known answer. If you ask questions that there is truly no knowledge other than a repeated experiment to figure out whether right or wrong, you're bound to do research that is way less creative and less valuable.
Okay. So one important question, because the entire headache world is very excited about this newer CGRP molecules. So how do you think that the basic research has contributed to that, and what are the expectations for the newer targets that are available?
So the question that you sent me was, given that 50% of the patients, or a little bit less than 50, don't respond to CGRP monoclonal antibodies, where do we go from here? So the answer is very simple. There is, as we said, there's more than one truth to migraine. Not every migraine is not a CGRP disorder. CGRP is probably not involved in migraine pathophysiology in all patients, and in those that it is not involved, they don't give it benefit from drugs that inhibits or neutralize CGRP pathways. It is really these patients that convince us every day that we have to continue to look for targets that will help us figure out, come up with new targets that can help patients that are not helped but by any of the existing drugs.
Right.
And the list is endless.
Right. So coming back to the previous question that we talked about the peripheral, peripheral sensitization and the peripheral inputs for the attack. So, do you foresee in future, like the peripheral interventions, like a lot of neuromodulation techniques are coming in, which are acting? Some of them are acting peripherally, and some are centrally, and some of the interventional models or blocks, for example. So, will that? Do you see a potential role of that in coming days for migraine treatment?
I think that every drug that acts centrally always puts us in a position to deal with unwanted side effects.
Yes.
And the risk of medication overuse headache. And the only medication that don't have medication overuse headache are peripherally acting drugs. You can't, without the central nervous system, you don't get medication overuse headache. So, by definition, if you deal with the headache, you will have to deal with peripheral targets. And the list is long, and it involves many structures.
Okay, and now two somewhat silly questions. One is, we know that migraine occurs more commonly in women, and a lot of theories have been put forward, including the hormonal effects. So, in your opinion, what are the most important contributors to that effect, that being more prevalent in women?
So, it's one of those examples where the human observation tells us that there is a difference. And we knew it, 100 years ago? Do we know any more than that now?
No.
I don't think so. I think that we are at the limit of understanding it, and it tells us that the animal studies we are doing has some limitation. For example, there is a huge set of data that come from our Standings lab that show that some of the migraine drugs and the migraine drugs that we use to generate migraine only works in female but not in male. One of them is the CGRP and the CGRP monoclonal antibodies. CGRP trigger migraine in men and women equally. CGRP monoclonal antibodies work on men and women equally. There is no gender or sex preference. Yet in animal, we find that these drugs trigger migraine, CGRP trigger migraine more in female than in male, and CGRP inhibitors work better in female than in male. There is a problem in our animal studies that explain there's nothing wrong with the animal studies. We are at a limit that doesn't allow us to understand the sex contribution to pain. It's not new to the world of headache. It's been since 1980. The NIH put on its flag to try to understand sex difference in chronic pain. What is the difference between the way women and men experience pain? We are 42 years later, and we don't have an answer. There are 100,000 of animal studies that look at male versus female. And we are not one step closer. We reached the limit, and we don't know. Why the clinical studies probably have the best chance to move us into the next level. We just need to figure it out, because the animal studies are disappointing about it.
Right. So that's another mystery to be solved. And the last question is about, we are talking so much about migraine. The word genesis of the word migraine from migrainea, hemicrania. So hemicranial headache. So physicians actually put too much money on the, unilateral headaches, hemicranial headaches. So why do you think that migraine headaches are unilateral? At least in 60% of the patients.
Well, the easiest explanation is if you bang your finger here, the pain is unilateral. It doesn't come in a second finger, right? If your headache is unilateral, it means that pain fibers on one side of your head get activated and not on both sides.
Right.
I think that the more difficult question is to explain. It's also okay to explain the bilateral migraine. What is difficult is to explain migraine that switch side, that goes from either right side or left side within the same attack. How is it that so many patients, I have it on the right side, and in the middle of the attack it will move to the other side but leave the first side, not staying there? So patient where it starts in one side and spread to bilateral is okay. Patient where it goes on both sides is okay. Patient where it stays on one side is okay. But when it shifts from side to side, we have no idea. We simply don't know. We have several hypotheses. Hypotheses are only good until you get data. Without data, they die. You need data. We don't really know how to study it, how to create activation in one side of the head with pain fiber and see a case where it moved to the other side and leave the side. We don't know. It's beyond our technical limit or technical thinking right now.
Right. So thank you, Professor, for a very enriching, interview and knowing something about the basic neuroscience and its contribution to the migraine research. And some of your philosophical comments are very worthy of pondering by all of us. And I think that in the days to come, the researchers like you and the generation of researchers that have passed under your tutelage will unravel the mysteries of migraine and will know much better and will be able to treat our patients much better. Thank you very much.